I
Hello.
Happy Monday, folks.
Happy Monday.
Hi.
I just played the game of putting my glasses somewhere around my apartment, losing them, and then running in a circle, trying to find them without wearing them, of course, and that of course made it harder to find them, which is just like the most ironic, terrible thing.
If you are wearing them and you're running around looking for them, then you've got issues too.
No, that's I had them on my head once, and I was like, "Where are they?" And I was like, I couldn't find them. There's definitely like weird places you put them, like the place I always find them is like somewhere in my closet because like I had to like take them off or something. But I remember one time there was something in the refrigerator. Was that might have been car keys though? That was like a long time ago. That was yeah. These things happen, you know.
Yeah, all the time to me. All the time.
Racine, are you in like a garage? Now you have a plant friend? I
No, it's not a garage, but kind of. I have all my toys here for electronics and stuff. So yeah, it's similar to garage.
You build stuff?
Yeah, I try to. I like sim racing, so sometimes build steering wheels for driving and so on. That's fun.
What about your plant? I don't remember the plant there before.
It migrates over the house. Now it's in my room. So yeah, it's just really old plant. I don't want to throw it, so it's here.
Is he your plant friend?
Yeah. I sometimes talk to it.
Does the plant have like shared custody, like half time in one part of the house, half time in another part of the house?
Yes, exactly.
No, he just knows all the secrets.
Hello.
Hi there, Patrick.
Got some interesting audio feedback there, Patrick.
Oh, great. Again, I'll try to do something.
Five minutes, so let's get started. So we have the first topic in our agenda. It's drawing the line between user configuration of applications and image compatibility on a node. I believe that's coming from you, Brandon, right?
It is. So this was kind of a thought process as I was thinking through some of the different scenarios here of what are some of the implications of what we've been designing going to come out to be? And can we avoid any issues that might cause problems for users down the road? And so the scenario that I'm thinking of is, hey, you could build images for application specific things like talking to a database, and I'll build my image. I'll have all the database code that talks to MariaDB. And then someone wants to run on Postgres. So you then say, hey, I've got this image compatibility thing. I can make the same image work for both. Anybody doing this today would just make 2 different images, 2 different tags, or ideally just have some configuration application, but we're ignoring that part. If you did it with 2 different tags, it's easy. The end user can pick and choose and say, I want to do this or that. If they tried to use the image compatibility for this, that means that then now they need to put on their node information about this node is designed to run images that have Postgres in them versus MariaDB. That becomes a very specific scenario there where people might not care about that for all their images on the node. It might just be an image on the node. And now you're blocking every other image that they want to run. So I worry about crossing the boundary between here's an application configuration or a specific setting there to talk to an application versus the line of wherever it is for here's physically what the node is able to provide that we're running on.
Yeah, so the way that I've been I agree with you. And the way that I've been thinking about it is that there could be some subset of compatibility information that a scheduler would be interested in. So for example, this usually comes down to resources that are specific. So the scheduler, for example, isn't going to want to know about something specific about databases. It might want to know something about IO patterns if it needs to schedule the application to a node that has a particular kind of storage. That said, I don't think that we should put a hard limit on what people can describe for metadata annotations. If someone has a wackadoo off use case where they have a cluster that is just running different kinds of applications and databases, and they absolutely want to use the compatibility like they're free to do that and they can write their own tools and stuff. But for the core stuff that we're interested in, I do agree that it's a hard distinction. And I think probably a strategy that I'll propose is that we when we first start and we make plugins and implementations, we focus on the core things that are really important. So like the simple things. So like architecture, for example, attributes of the kernel, GPU, like the most basic, like if we were cooks and we were making recipes, we would be focusing on like the core ingredients. And all those people that want like saffron with their rice or whatever, we'll just ignore them for now. And then either 2 things will happen. Like either there will be another core thing that bubbles up that we totally missed just because we missed it. And then we'll talk about it and we can add it. Or there could be kind of these off-label use cases, the people making the saffron rice, right? And they will figure out a way to make their own compatibility artifacts that meet their needs without us needing to say like, yes, saffron is a key core ingredient for this here. So I agree that there's this distinction that needs to be made. I think all we have to do is decide what are the core ingredients that we care about, but not limit other people from caring about other things too.
Yeah, I think I agree with both of you, but my idea was not to limit users what they can put in there. We can just recommend because we have no control over that, what users put in their manifest even today, right? With image manifest or whatever, how they build stuff, and there's a free word. But I would just set a recommendation that if you create a compatibility, you should consider only a minimal requirements against the host that you're able to launch a container. So for example, if you have a storage, like your application requires a block storage, without it cannot run, you could put this into compatibility, but user configurations that are kind of, let's say, meaningless is just one variant that should not land in the compatibility. And I think we cannot control what people will put in there, but we can just write some recommendations and say the tool we write are not compatible with this, what you are specifying in there. If you are, I don't know, putting some users configuration variants and you have your own tool for that, then fine by me. Do whatever you want, but don't expect from us that we will make our specification compatible with this what you tried to achieve or something like that.
I think the place that got the most of my attention was when we kept talking about the MPI version, but even before then, we were also talking about libc versions. And so I wonder if we want to be careful not to include those in whatever requirements gathering we do when we start committing the server to Git.
Yeah, so that I have to speak up about this. So MPI is like bread and butter HPC. It is in 90% of exascale applications. It's not to say it's always going to be that way, but it is so important that you get it right. And so for the HPC use case, like we could be using containers, but actually we may just have a compatibility artifact that's describing an application. So again, that's kind of off label, but it's something that we want. We want to be able to use these standards as well. And so MPI isn't something that can just be disregarded and thrown away. And I'm not saying it should be a core thing that we force everyone to care about, because lots of stuff in the cloud is not going to use MPI. But I think we need to consider designs that would allow the HPC community to put their metadata about MPI in the artifact specification and use it. I don't think we should prevent that. Does that make sense? And it's not just MPI, like that kind of example extends to any kind of metadata artifact that may not even exist yet that someone might really care about.
Patrick?
Yeah, I was actually wondering a bit, could you actually go through with, when you say MPI, what do you, I mean, you don't put in everything in a container and then run with it. Apparently you have a container with an application, probably. Now you want to have at least a compatible kernel for your particular MPI version. Is there something else that is happening in here that we should consider?
So the best example I can give for MPI is with like a container technology like Singularity. And actually doesn't have to be Singularity. I'm just providing Singularity because it's more seamless. When you have an application in a Singularity container and you want to run it across your HPC nodes, what you actually have to do is bind the MPI in the container, like the library, with the library on the host. And you have to get that match right. So you have to get the flavor of MPI or the implementation. So like OpenMPI versus MPitch versus Intel MPI, and the version. Even subtle differences in version, your thing will not run. So although it is a library, it's more on the level of something that is going to bind to the host, that has to match the host. And that's very different from the use case of like, okay, I built lamps into a container that I'm going to run on Kubernetes, and that doesn't really care so much about what's going on in the host node, but I just need to make sure that those containers in the index job, for example, in Kubernetes, can work together, and that my network in Kubernetes is good enough to support that. So it has like elastic fiber adapter or something like that.
Okay, so you said match the version of the library in the container with the one on the host. Could you?
Yeah, so Docker, it would, if we were running Docker, it would literally be like a binding or a volume of just that file. For Singularity, it's called a bind, so it'd be like dash
Okay,
B,
okay,
like
exactly.
the exact library, like zoom.
Yeah, you mount it in from outside or something. Okay, and then of course it has to match like 100%.
Yeah.
Why
Okay.
does it need to be mounted in versus just included in the container image?
Pardon?
Why would you need to bind mount in the MPI libraries binaries rather than just including them in the container image?
Because you're leveraging everything on your hosts. I don't think I have a good answer for that. I can get you a better answer, but I know that's what people do.
Yeah, it feels a lot like I'm going to write a node application. I'm just going to mount the node version from the host, and that's exactly what all the container images were designed to avoid having to do.
Yeah.
Might I interject? You have MPI libraries on the host that are specific from a vendor for the hardware. And so you mount those in to the containers so that the MPI libraries can use them to run at speed.
Boom. That's it.
So in those cases, would the compatibility then be more appropriate to be for that specific hardware versus the MPI version?
So the MPI is a standard, and so all the headers for the ABI can actually be, they're already standardized, so you can swap between them safely.
Theoretically speaking.
With fun exceptions, but our friends in Europe also have the glue layer that lets you swap between them via page and OpenAPI. So minor things, they aren't really relevant for this purpose. But the libraries sit on the node and they're provided by the vendor. And so if you want to take one container that has your given job and then run it on 10 different clusters with 50 different types of hardware, then you need to be able to mount this stuff in and have it work at speed. Otherwise, there's no point because it's so inefficient that you might as well be running it on your laptop. And it's the performance difference is several thousand times in some cases than just using like straight up IP.
But the containerized application, I mean, do they anyway have identical header files? So when you compile it, do you need the exact version you are compiling against? Or is it okay to have, okay, these are the MPI version, this and that headers, and then they work against the implementation, whether there are a few flavors of those? Or
The
how
headers
picky
are
is
always
this
the
thing?
same. That's part of the API compatibility. That way
Good.
it
So
can
you
just be done live. You don't have to recompile.
Okay. Okay.
From the user standpoint, I guess the question I'll throw out there is, should this be a compatibility or should this be a tag? And you just tag your
We've
images
been
and say,
doing it with tags. We've been
Yeah.
hacking it with tags, and I think it should be compatibility. I think this is like the most important thing. One of the most important things for compatibility in HPC is that. And there's a huge cultural component too that HPC is about building things on bare metal, and containerization has been fairly successful. A lot of centers have container technologies, but there's still like a lot of pushback, right? And part of our work is, and containers offer huge benefits: portability, reproducibility, and even sometimes they can, if for example you run something in a singularity container and it kind of chops off some extra Python paths, you can actually get like a faster startup time than not with a container. So I think it's also part of our job to demonstrate that the value added for containers in this ecosystem. And so part of that would be saying like, okay, this problem that we currently have with MPI could hugely be helped with this particular approach, for example, using compatibility. And right now it's, this varies based on the center because a lot of centers do things differently, but right now it's primarily like a user derived thing. Like I will just make sure that when I run my thing that the MPI is going to match, given that I'm using a container, and I think we can do better than that. Brandon, sure.
So yeah, by moving it from what was used to be a tag or just building your own images and only using a single version, to saying I'm going to have multiple versions of MPI supported using this compatibility spec for my one image, now means if you deploy this across multiple nodes in your cluster, that you might have some nodes pulling different versions of MPI depending on what node they fall on. Is that okay for the workloads?
It also gets a little worse than that. Is that there can be differences in the processors on the nodes and the jobs and the GPUs that are there. So if you compile it against the highest optimization for one CPU architecture or one step, you want to be able to run it on several nodes that might have different steppings, and that will also explode either SIG-IL or it'll run slower than it needs to. And these complications start just really stacking up.
But the direction I'm going here is, if you are running that in that environment where you have 2 different CPU types, 2 different versions of MPI, all this different stuff in there, can you deploy this in the network and have them all? I'm assuming you're kind of doing like a MapReduce or some kind of, parallel operation you can distribute across multiple nodes. Can they then return back and talk to each other when they need to if they're all running different versions of MPI?
Yeah. That's not going to be an issue.
Okay.
Luckily enough, that's pretty well standardized. And any inherent limitation, like jumping between different network types, will just have to be filtered out beforehand. Like you can't cross between InfiniBand and OmniPath. It just won't be allowed. Or at least I think it's safe for us, for anybody to just say no. It's definitely going to be user who wants it one day.
Yeah, it seems like there always is.
All right. I think we've beaten that one enough. Marcin, you want to take it away with the use cases?
Yes, we can go through the use cases right now. Dirk, do you want to share your screen or should I?
Do that. Let me try to find the image again. Sorry, I'm a bit voice challenged today. So I think we stopped here last time. And the rule was last time to not have more than 5 here. Just kidding.
So we're on number 6.
Yep.
Yeah.
Yeah, I'm a bit confused about what the difference between workflow developer and deployment engineer is, but the rest seems obvious to me.
I guess the workflow developer is going to be putting like annotations on their workflow. So if you're familiar with a lot of workflow tools, you can do things like this step needs this much memory and this step, things that kind of go to a scheduler and aren't really about image compatibility. And so I think this one is saying like, I should be able to add things like that are relevant to the resources or could be relevant to the compatibility spec, like, needs GPU. And this also kind of goes into what I was talking about this weekend about how we will want potentially some slice of a set of compatibility artifacts that describe like a family or group of images under some common, URI to be able to be, used by the scheduler. So that's where I see the first part. The running times, that feels out of scope. Like that is going to hugely vary based on where we're running and what we're doing. So my inclination is to I don't think we can cover like that there's going to be some compatibility annotation for a running time, but I do think that we could have, let's see, I should want to be able to annotate containers that go into my workflow. It does seem reasonable that some workflow developer could make annotations on their application containers that eventually they could use in their workflow tool. That's again off-label, but possible.
I'm not sure if I understand correctly, but in that case, can we just run annotations from the image manifest we have today for this kind of information?
Well, I don't think it matters where. Oh, you mean for running times or for the compatibility stuff?
Basically for both.
Wouldn't that just be one of the design? That would be Brandon's design, just to like throw everything into annotations, wouldn't it?
Yeah, kind of. But what I meant basically here Let me open that.
Yes, the question is, are we annotating the containers or are we annotating some kind of artifact with the compatibility spec?
Yeah, I thought to annotate container directly over the existing spec we have today.
Then it's back
Yep.
to like wild westiness. There's not going to be a way to agree on the namespaces or, I mean, I think most of what we're talking about, we could just throw random stuff into annotations and call it a day. But I think isn't the basis of this working group that that's not good enough?
I like annotations.
Yeah, but
Yeah, you would like annotations. Brandon's like, it's gonna be annotations.
I guess the question might be going to, if this is something that we can put in the container image, it's already defined as a feature of the container image today, then do we even have a use case anymore? It's already functionality assist.
But couldn't you say that about every use case in this document?
All right, meeting over.
Okay, we're done, folks. We decided we don't need a working group or a spec. We're just gonna throw everything into it. No, let's not do that.
I think that you still need to give semantics to the annotations, right? So I think annotations by itself don't give the
Correct me if
standard
I'm wrong,
interpretation.
but annotations don't allow us to do more complex types. Like you can't do an annotation that's of an array or a dictionary.
It's a string map.
Yeah, so you would actually have to like embed like a JSON string as a value to do more complex things.
People do that.
There are folks that have tried to do like arrays and whatnot in there. They'll start numbering each one of their annotation entries and have multiple ones. It can get ugly. Fortunately, so few people use them that it hadn't really turned out to be a problem.
Just my thought that if we're going to annotate the specific hardware, the compiler, and the other things that exist for these containers, having a more complex data type would make this a lot cleaner for everyone involved, especially since we're already in JSON.
I think we're getting caught up here with the use of annotate. I don't think the intention was to talk about annotations here. I think the intention was saying, as a workflow developer, I want to be able to define compatibility metadata that, that describes the resource needs of the applications in my workflow. Because the whole like how we're representing this is something that we will have to decide. Maybe annotations will be involved. I don't know, but like it's not specific to this particular point.
yeah, that's a better explanation because I thought of something additionally to compatibility spec that we have some wild annotations, and I thought just to use the existing image annotations, but what you just said explains that to me right now. That's cool.
Are we duplicating 3?
Yeah, it kind of feels like we have that in a way already.
Is the intent, Vanessa, to annotate what the hardware requirements are of the node or like of the job here?
I think the best example that I have in mind is that like some so to step back, when I say application, I mean like a step in a workflow, and that step in the workflow would be given as a job to the workload manager to assign somewhere. And so the case that I have in mind is a particular step may expect to have a particular pattern of IO in the sense like it's going to run better if you give it the kinds of storage devices that match to that. And this is something like we already have a really nice set of different kinds of storage for different jobs, but it's so niche and detailed that users don't even like, it's not something that people are asking for when they could. So that's a really good example of why we'd want it to belong in something that's automated, that can we can do basically kind of like a definition of the pattern of the application step a priori somewhere else before, then put that in the compatibility metadata. Like if you can try to match to this particular kind of node that has this, that will allow for this pattern, and then it's going to run a lot better. Does that make sense?
Yeah, I just argue that that's one step up from OCI land. and that's in scheduler land or orchestrator.
Yeah, but the
My thought would
scheduler,
be-
this is what I went into this weekend. The scheduler needs to be able to take these compatibility artifacts across a family and get an abstract or computed view of what is possible, given what is possible in terms of like the application images that exist, that it can then help to sub-select the resources. Because let's say that like if it isn't able to do that, it might give you a node that none of your applications could actually run on at all.
Yeah, I mean, my thought here, or at least my hope would here, if any change to the OCI, is basically being able to answer two questions. Can this image run on this hardware? Second one is this optimal? And that's, as far as I can tell, the only things that would be needed for the scheduler, and everything else can be handled by the scheduler.
Yeah, I agree with that.
Especially for OCI, I mean, I absolutely want this to stay as simple as possible. For my own sake, very, very, very much so. But just being able to ask a node, hey, does container X, will it run on this? And is container Y optimal to run on this? Like, is it, and for whatever, and however that's defined by the OCI runtime, really.
Yeah, though, you can imagine a case though you can imagine us implementing something that is so simple that you get to the case where you actually have a choice of 5 different nodes. And because we've implemented it so simply that it doesn't have more granularity of detail, there could be 2 of those nodes that it's going to work really well on, but we have no idea, so we randomly choose and we choose one or the other thing.
Yeah, that's just the way of things. You have a cluster with 5,000 nodes and they're all basically the same. Maybe a way to quantize, to say how well the compatibility is, something like that. But at the end of the day, I just need to know if I can run on this and if this, it's an optimal setup.
Yeah.
How optimal, you can always say, 100% or 10%, who knows? But, just something really simple that the runtime can tell us, hey, will this config.json play nice with this host? That's what I'm hoping for.
But if the user can define a metadata attribute that's going to help them to do that, who are we to limit them from doing that? I guess I'm agreeing with you.
I would argue that would be in the scheduler and not in the OCI.
Yes,
definition.
But the scheduler needs to use a slice of some kind of set of artifacts that are provided, because the scheduler is getting information about the application from probably the workflow tool, but then also once it needs to actually choose and match the specific application image to a node, because it's often the scheduler that's going to pre-pull an image, because you're not going to have, 1,000 polls directly happening on the node that happened with Singularity Hub. That was really bad. I had to refactor the server. Anyway, that's a different story.
No, I've gotten banned from Docker Hub for such fun things too. No, well, then maybe there's just a way to dump annotations as to the hardware and what's available, and then what was there when the image was compiled, and preparing a tree with the scheduler is cake. So putting out that logic into the scheduler saying, hey, if these all match, we're good. That's fine. And maybe optional ones to determine the amount of optimal state.
Yeah,
something like that would be fine.
Too. Like, this one's required. Like, if you don't give me ARM, I'm gonna throw up on you. But these other ones, this would be really nice to have. But if you can't do it, totally cool. Like that. I do think we need something like that.
So that goes back to my point of, I think annotations can handle that just fine. My only complaint is doing it as a string is clunky at best. And getting it from the runtime would be really nice, because the runtime knows what it can run on. Although I don't want to be too specific about any of this, because the variations between these runtimes is excessive, and the changes in the hardware and all the niche hardware that one might have to worry about is large. And
I don't think
such
it should
things
belong
as a
in
standard
the runtime.
seems counterproductive.
This goes back to the point that Brandon brought up in the beginning, like, where do we draw the line? I don't think we should be putting all of these detailed things in a runtime. But the point is that if the information is in a compatibility spec, that an advanced tool or a scheduler or whatever knows how to read and knows how to find what it's looking for, it sort of does a filter or a pruning of the potential options that are available in doing its node selection. So then maybe when you get to a node, assuming you're pulling on the node, which is bad practice, don't do that. But assuming that you're doing the pull there, then the scheduler, by way of using the same metadata, not in the runtime, is actually, scoped what the runtime is going to pull based on the node selection, if that makes sense.
Yeah, so couldn't we just throw that under one annotation called compatibility? And then
I mean, we
offload
could, but
that
we
to
have that
somewhere
now
else?
and people aren't using it.
Well, of course not. But this is the OCI standard, not for that part. That's one step above OCI, isn't it?
Well, I think we need to have this in as part of this compatibility spec, because we're going to be building tools toward the core stuff, toward the core things that everyone cares about. And then our other needs are going to trickle into that. But saying like, yeah, just throw the annotations. I mean, it's been that way for many years, and that has not solved our community's problems as a solution. I'm not going to list the reasons why, but just to say that it hasn't.
No, I understand fully, but my point is that would require us to actually all agree about what we put inside of the compatibility label.
No, it wouldn't. It would only require the person that has right access to the registry for an image to decide what they care about and what they're going to provide. So like if, NVIDIA is going to decide what they care about for their containers, and it could be depending on how we design it, if we do sort of a separate design where we have an artifact and separate from, the manifest, then we could actually have a case where someone's like, I know NVIDIA didn't care about that thing, but I actually care about this other set of attributes for these NVIDIA containers. So I'm going to make a separate set of artifacts that my tool has just a little database or whatever that has them paired together, so I can get the metadata that I need for it.
And so how does annotations not solve that?
Because they're not solving it now. And also, as you said, like there's more. Really what we need are kind of definition of namespaces of these different things, because there's no reason different communities are going to define namespaces of compatibility metadata. They're important to them. And whether or not one community decides to choose one as core to package along with their images is fairly subjective. Like, yes, there are going to be these core things that most people choose, but there's going to be like this intermediate zone of things where some people are like, yes, that's absolutely essential for our resources. And then other people are like, I do not give any, I won't say that word. But yes, so we need to have these metadata attributes defined in the same namespace, because we can't predict in advance which ones are going to be core and which ones are not. And if we have like a compatibility artifact and a totally separate thing of like the Wild West of annotations, well, those two things can't be interchanged because they're different.
So Patrick had his hand raised for quite a while.
Yeah, I'm getting tired in my hand.
Sorry, I can't see people once the screen sharing goes on.
No worries. Actually, so what you sort of were arguing about is that basically we need to be able to express the set of stuff that needs to be there so that it actually runs, and then actually we need to be able to express another set of things which makes it more optimal. From whereas optimal set comes from, I mean, this could be again these deployment engineers or whomever that actually define a bit better that yes, it will run on these nodes, but actually if we add these constraints, then it will run better because it gets the better CPUs or whatever for this particular thing. I think that's what we want to express. Then the other thing is that should the specification stop there and say that these are the things we need to express? Do we actually need to figure out exactly how the runtime and these containers and nodes are going to discuss this between themselves? Is it enough for this specification to just be able to express what we want and then start wondering actually how this is done a bit later?
Yeah, I don't think we need to decide like the groups, the metadata thing. I think we're literally just talking about like the specification for the design of a JSON blob somewhere needs to potentially meet this use case. I don't think we should be kind of embedding our preferences for exactly what those labels are or how they can and can't be used, because that's biasing. Like, I mean, it's adding our bias, and that's I don't think that's something that we should do.
Brandon?
Oh, Marcin was next, but I'll say that two things. One I threw in the comments already, which was kind of be careful how much we're putting on the scheduler, because there might be information that you're querying for the scheduler just doesn't even know. It might not have all the details Node has, so it's got to run through all these checks over again. The bigger one though that I wanted to point out was that annotations themselves, while we're saying it's the Wild West, we follow the reverse DNS notation to put the stuff in namespaces. So we have a way to do namespaces with annotations. And so that's what OCI does today. It's org.opencontainers.whatever. You're using something from the OCI. If you have .com.supercomputer, whatever, that would be some other group's annotations that they would have control over. And so, yeah, it is a free-form string equals string, but people could have namespace ownership of those fields.
Yeah, and
Marcin?
the design, the proposal that I put in actually uses that same design for the annotation, but the distinguishing factor is that it's put into the space of compatibility specifications, so that down the road, when we have tools that know how to interact with compatibility artifacts, whatever that may be, they're included. And there aren't like two avenues to kind of determining compatibility for like the cases that we think are true and the cases that we think are not, which use annotations, and this one uses the compatibility spec. We want to have one avenue that you go down with one metadata path when you're doing some kind of compatibility check.
Yeah, I just wanted to say that I kind of align with this what Brandon said and Nathan as well, but also to provide some feedback to Vanessa about that, because when we are talking about this compatibility containers, I always was saying that we should think about minimal requirements that container run on the host, and it's in context of core plugins for that we will develop as a group. And we also agree that different groups, specialized groups like HPC, NVIDIA, or whatever, they can create their own namespace and maintain their own tools and plugins. And this is fine. So if Vanessa has a use case that she needs to provide different sets of storage that has some kind of rank, how they perform and so on, that's totally fine as long it's not maintained by us as a group. My point is, like, we could have this statement that compatibility working group or OCI is providing a way for you to define your own compatibilities, and you can use our own plugins, which are basically targeting the minimal requirements for the host, and that's all. And don't expect we would put something else. Whatever you do on your own and in your own organization, it's up to you. But we should be kind of stopping people to put their high-level use cases into the core stuff. This is what I wanted to say, but if it makes sense.
Yes, that was very well articulated, and I totally agree. Yes.
Okay, so I'm not sure how we move forward. So I think there were a lot of good points raised, but we haven't captured them anywhere. Do we want to take them to the HackMD meeting minutes, or how do we want to move forward with those points?
I think
Just
for each of these
postpone the
points,
discussion.
we might just do what we've been doing, is to just very generically look at it and be like, even though this may not be something that we consider core, is this something an off-label use case that a compatibility artifact could provide. And so someone putting, designing compatibility metadata for containers that go into a workflow, to me, that seems fine. That seems like something that should be possible. But I don't know how we got into this side thread about annotations, and it feels like it was distracting from like just the point of like, is this a use case that down the line we will be able to support even indirectly? Yes or no? That end of conversation.
So I would say just let's move forward to the next point, and everything will be clarified during the proposals review. So yeah.
So is everyone fine with the way that I reworded this point? Is that good for you? I take that as a yes.
Okay, let's get rid of that annotate again. People are gonna get up in arms about annotations. So again, I think this is saying, could there be an off-label use case where akin to like for the HPC use case where it might be really important to label something about MPI, could there be an off-label case where I'm like, you know what? My system is entirely based on webhooks and callbacks. I'm not going to comment whether that's like a great design. It kind of sounds questionable, but could we allow someone to use the compatibility spec that says something about them? Or more generally says something about provenance?
Does this mean that I could create an image that would potentially exfiltrate data from private organizations?
I don't think the webhook would be in the image. I don't think there'd be like a binary, like just grab this binary and run it in YOLO. I think it would be more like this like a name of something that, that something on the system knows how to then call.
But
like
for
it
me,
would
even if it's just calling and hitting a remote web interface and saying, hey, I'm running this over here, that could be telling if it says, oh, that's an IP address server in the DoD military infrastructure. Now I know what software they're running.
No, I don't think you'd put the address in there either. So like, let me think of a good example. Let's say that you have
source IP.
Let's say that you have a system. Let's say that you have like a system that it's just tuned to running one particular kind of workflow, which is like a thing. Like there are entire clouds meant for running like, Nextflow or whatever. And Nextflow is, and you're actually using it like a state machine. And basically the next place that you need to go, the next application that you need to run has some kind of identifier. And so you basically use an identifier from one of these, I don't know, and I'm going to say annotation from one of these metadata attributes to know which named callback to use. The only thing that's kept here is the callback name, not the like address or like the actual or binary or anything like that. I would say people are getting super caught up in these use cases, and I don't really know why, but I think we could scrunch them down to like, as a workflow developer, I want to be able to define the resources and metadata that I need for my containers to run with my workflow tool, and then just call it a day. And we don't have to go into details about webhooks and callbacks and provenance, like just combine them into one. The workflow developer has needs. We hear you, workflow developers.
So I can't go like Log4j discussions now and talk about, can we embed some kind of like funny syntax that can expand to run executables for us?
I mean, if you really, really want to, if that's like, we totally can, but we have 10 minutes left, Brandon, so you got to make it a little less snappy.
Number 8.
Yeah, so I think we agree to not consider this one, right? Because
Yeah, and I
the
think we
security
should tweak.
implications are too difficult.
I think we should, as workflow developer. Okay, my proposal is to delete 7, 8, and 9 and change number 6 to be generic about a workflow developer that is, as what I said before, as a workflow developer, I want to be able to define compatibility information for my workflow tool and then just call it a day for the workflow cases. Because there's too many what if this and what if that, and we just want to make sure that we consider the workflow developer, that the workflows are running containers that need to have nodes that work well with them. You don't have to use, you don't have to use special Snowflake, but as a workflow developer, I want to be able to define compatibility metadata that is needed for my workflow tool. Done.
The needed compatibility metadata.
For my workflow tool. People get sensitive when you call them snowflakes. Well, all of our HPC clusters are snowflakes. So thankfully, HPC clusters are not people and they don't have feelings. At least we don't think so. I say this, and now I'm imagining like a server like sobbing off in the corner of a data center, like she called me a snowflake. Oh, I'm special.
But normally that's a good thing. But anyway, outside containers, I mean.
Nice. The server is down. Just needs a hug. So I can clean up 0.6 to be more succinct, but yeah, I would just X that one out, number 9.
So I think we have this point already. So I think this is point 1, right? Point 10, I mean. 10 and 1 are the same.
Yeah, I think point 10 is pointing out that when you're moving down a manifest list, you actually don't want to honor the order. And I think that's sort of implied in number 1, but it's not explicitly stated. So maybe it's just something we could state in point 1. Does that make sense?
I would keep it as a separate point, to be honest. Because I read the discussion on GitHub about ranking the images and so on, and it got kind of hot discussion there, and I think it would be difficult to convince runtime maintainers to have a ranking image selection. But I think we can keep it.
Yeah, it's really interesting how a lot of these points are kind of erring into describing like runtime selection in terms of some component that a scheduler does. So I won't talk about HPC schedulers, but think of like the Kubernetes scheduler, which is composed of different plugins. One of them is a sort, where there's sorting and scoring, and I won't talk about. I mean, the scheduler is complex, but like we keep talking about these different facets that the runtime might do. So ranking the images, well, that's kind of like a sort, right? And it's going to be really hard figuring out where we draw the line between like the runtime tool has a really simple way to just like choose the right one. I know, but now we want it to rank and we want it to do these other things. And it's like almost turning into having, it's starting to smell a little schedulerish to me is all I'll say. Yeah, I'm okay to leave this point. I think I like this point because it made me think about something in a different way.
Sounds good to me in that case.
Okay, do we go over the registry use cases still? It's only 2.
See how we get.
The other option is that we look at Christian's slides. Not sure if you saw that on Slack. He just posted it like an hour ago.
Oh yeah, FOSDEM is this weekend. It's like actually over the weekend, which I realized last week.
I don't think we'll get through all of his slides in 3 minutes.
Yeah, I don't know how he can do 26 slides in like his 5 minutes talk, but I'm sure he manages.
Oh man. Okay, so when I make a talk, I usually have like over 200 slides. But what you basically do is you just use the slide as like the animation so that if someone looks at it statically in a PDF, they have the same experience as someone that is actually watching the talk. Versus with actual animations, you just get like boom, everything on one slide, and then you're just like, too much information. Where does my brain look now? I don't know.
Number 1 looks good to me, other than I think I
Yeah.
want to change the word author to operator or maintainer.
Isn't it user, actually?
Probably.
Probably both.
Yeah, probably the user would interact with some kind of tool that would, know how to interact with the registry that would then take their needs and then be like, okay, this is a match for you. So probably both, yeah.
So we called it operator. Registry operator.
That also sounds good to me.
I wouldn't be surprised if I was the one that wrote that one. So I'm happy with that one as well.
Hooray, we made it.
Now we're flying. Are these the last two? The spec maintainer and the security administrator? And then it's like done?
Yeah.
Oh, wow. We're almost there. So are there any folks in the call that are going to submit other proposals? I would say if you're interested in doing that, probably to start thinking about it now. If we go through these 2 sets of bullets next week, then we'll be done after that. And I think we'll probably be ready to look at proposals. Does that sound about right?
Yeah, that sounds good. Maybe we can have some kind of deadline for proposals or something like that. Can be discussed the next meeting if we are able to finish the use cases. Because today at the beginning we had just 2, and then we improved.
Yeah, that sounds good.
Okay, then I wish you a good evening and see you next time.
Yeah, one quick
Thank
note.
you.
Should we asynchronously give Christian feedback about his slides in the Slack since it's this coming weekend he's presenting?
Yeah, I looked briefly over it already. So I guess everyone should do the same and like leave a comment. At least that you've seen it.
Yeah.
Thanks.
All right. Sounds good. Thanks, everyone. Have a good week.
Cheers.
Bye.
Bye.
Bye.